Alright, so we're continuing our journey towards a better understanding of the base 12 version of pi. What I was doing in the previous series of videos was showing you how to construct this diagram for 360 degrees. What we did was we plotted all the points on the circumference of the circle that then created, each of those was a specific degree point. So we created all 360 degrees. We had lines going through, and what was unique, or what is unique about this particular diagram, is that all the lines that are going through those points that define the degrees are actually lines with a thickness to them. They have a thickness of 0.06 root 2, 2 times 0.03. So you can see that on this close-up of that section of the diagram. So we created a special type of unit that then made up our circumference. Not just a single point, but actually a large circle with two smaller circles inside of it. Those two smaller circles were sections of the diameter, and then there was that empty space around, and that 0.06 root 2, that empty space is evenly dispersed around the circumference of the circle. Usually when we think of pi, we think of a solid line with a little bit of a gap at the end that gets narrower or smaller with each consecutive decimal place, and we know pi goes on for millions and billions and trillions of decimals, so we know that that small remainder is very small, but it still stays there. It never goes away. So it's actually one part of the concept of pi is that remainder at the end, and we call this an irrational number, and we say that pi is transcendental because that little gap never goes away. So what we're doing in this model is, instead of just having a solid line with a gap at the end, we're taking that gap and dispersing it throughout the circumference of the circle, and that enables us to actually line up 360 degrees with the concept of pi. We're not really able to do that in base 10. We're not able to create this entire diagram in base 10. It doesn't exist in base 10. So this comes from the fact that the real difference between base 10 and base 12 lies in the division of the 1. When you divide the 1 into twelfths instead of tenths, you get different sized units. The Cartesian plane is a denser grid. The lattice points line up differently. So we have access to new geometry that we didn't in base 10. Because the pieces are smaller that we're working with, we have access to a pattern, a type of dodecagon. This is what it looks like, and you can see I got two examples here. One's in base 10, one's in base 12. And you can see that one looks bigger. That's because one in base 10, the individual distances between the lattice points are larger. So the pattern, both these patterns are made up of units of 0.5 root 2. Each of those lengths is 0.5 root 2, but in base 10, that's a longer length. So in base 12, you can see that this pattern shrinks down, lands on the 1 in a way it doesn't in base 10. And this pattern is what's enabled us to create the diagram for 360 degrees. So now what we're going to do is we're going to look deeper into the circumference of the circle, taking these units that we've created and looking at them more as we enlarge the circle. We add more and more points. We're going to start adding literally millions and billions and trillions of points on the circumference of the circle, and see what happens as we zoom in on that circumference and it gets more and more like a horizontal or vertical line, straighter, closer to a straight line. What happens to this geometry? What's going on there? So this is the next phase of really understanding base 12 geometry and the geometry of the circle from a base 12 perspective, and really see that, is this pi? Is this new geometry with this empty space kind of dispersed around? Is this a more accurate model to represent the actual physical universe that we live in, that does have empty space kind of dispersed evenly throughout it? We know when we go to the really small, to atoms and molecules and electrons and protons, there's a lot of empty space in there. Is this the geometry that we can use to sort of map out that area? So we're going to find that out by just zooming in and see what happens. We're going to use this 360 degree diagram to do that, to just keep going in there, creating a structure, and again, sort of exploring and seeing what happens. So I hope you can join me for this new series of videos. Thanks for watching.